Hey guys, in today's video, we're going to be looking at what React.js is and why it was actually developed. I remember when I first started learning about React.js, the experience was a bit weird for me because although the syntax of React.js is quite intuitive and easy to use, and it's actually quite easy to set up a project that uses React.js, what I wasn't entirely sure of was why the library was developed and what sort of advantages does it bring to the table when you use it in your web applications. So hopefully by the end of this video, I can give you some intuition about what the library is, why it was developed, and in what sort of applications you might want to use it. And by the way, if you're watching this video, I'm gonna assume that you're comfortable with at least basic HTML, CSS, and JavaScript. Also, if you're new to this channel and don't know who I am, my name is Adi and I'm 24 years old. I'm a mechatronics and a software engineer, and I recently created this channel to explore topics like artificial intelligence, full stack web development, creative coding, and maybe some robotics down the line. So if any of those topics sound interesting to you and you'd like to be a part of my journey with this channel, then consider hitting that subscribe button down below. Okay, let's jump right into it. So what is React.js? So if you go to the official React.js website and look at the punchline at the top of the page, you'll see that it says that React.js is a JavaScript library that's used for building user interfaces. So what does that actually mean? What is a user interface? Let's look at facebook.com as an example. So when you navigate to facebook.com, a bunch of different components get rendered onto the screen, which allow you to interact with the website. So for example, few of the components are the top navigation bar, which allows you to navigate to your profile or the home page or look at the notifications that you may have. The actual posts on the page themselves, and these allow you to like the post and comment on them or share them with your friends and family. There's also a component on the left which shows you a list of groups or pages that you may be a part of. There's another component to the right of the page which shows you a list of friends and family members that may be online at the moment. And if you actually click on any of those users, then a chat bubble pops up which allows you to message your family, friends, and members. So each of these components put together form the user interface for Facebook. In other words, it's an interface which allows you, the user, to interact with the website. Okay, so in that regard, React.js is a JavaScript library which allows us to build user interfaces like the one on Facebook. But the next question that naturally arises is, why would we want to use React.js to build user interfaces in the first place? In other words, what advantages does React.js have over vanilla JavaScript? I'm going to argue that there are three main benefits or advantages of using React.js, and I've listed them on the screen at the moment, but I don't expect them to make much sense to you right now. But don't worry, let's step through them one at a time and see if we can decipher what they mean. So the first benefit of React.js is that it allows us to create something known as components. Now, what does that mean? Let's say, for example, that you were tasked with developing this web page that's in front of you right now. It's a Wikipedia article on React Fiber, but pay no attention to the actual article itself. And the task is to build just this single page in front of you and not the entire Wikipedia web application. So it's a rather simple task. One of the things we might do in the beginning is break this page down into smaller components. So we might identify that this page has a sidebar on the left of the page, a top navigation bar, which is at the top of the page, and another component, which is the content of the page, which is the actual information on React Fiber. So after identifying that there are three main components on the page, we might then go and create an index.html and style.css file and define the HTML and CSS for each of these three components over here. Now, after doing that, we might realize that we want some user interactivity on this page. So to do that, we create an index.js file and link it as a script in our index.html file. And we might write some code that looks like this. So this is just an example, but what I'm trying to show here is that we are creating an event listener for the edit button on the top bar, so that when the user clicks on this button, some code gets executed and maybe the content of the page changes. Okay, so let's think about what we did in this example over here. We first identified that our page should be broken down into 3 components, which is the sidebar, the top bar, and the actual content of the page. We then noted that by combining these 3 components, we'd be able to render the page as we are required to do so. But after doing that, we went and created 3 distinct files, which is the HTML, CSS, and JavaScript files, and split all the code for each of the components in these 3 locations. In other words, the HTML file, for example, hosts the code for the sidebar, the top bar, as well as the content of the page. Now this means that eventually, as our application gets bigger and bigger, the HTML file, for example, is going to contain HTML templates for maybe 50 or 60 different components, making it very messy and very difficult to work with. And if you don't believe me, take a look at the HTML file for this React Fiber page, which looks simple on the surface, but has a lot of lines of code within the file. So React.js says that splitting your code into 3 distinct sections, an HTML, CSS, and JavaScript file, which may be shared by different components, is actually a bad idea, and it's not very scalable. Instead, what React.js tries to enforce is to do something similar to what we had thought of in the beginning, which is create 3 encapsulated units of logic, which represent all the code for our components. So what does that actually mean? It means that we want to achieve something like this, where we want to encapsulate the HTML, CSS, and JavaScript for the sidebar in one location, and do the same for the top bar and the content of the page. And then later on, once we have done this, mash all of this together to actually render the page that we had before. So what does this actually look like in terms of code? So take a moment to look at the code on the screen at the moment and see if you can identify anything that's different to vanilla JavaScript. So you should have noticed that lines 12 to 14 actually are a bit strange. It seems like the entire file is just plain old JavaScript where we define objects and functions and have return and export statements. But the difference is that our sidebar function is actually returning HTML. And we're able to do this by using React.js. So when we use React.js in our application, we can define files called JSX files and actually define functions which return HTML from them. Now that's very powerful. So for example, with the code on the screen, we can see that lines 1 to 3 define the sidebar styles, and these are just CSS styles like the font family, the font size, the background color, and so on. Then we define a function called sidebar, and this function returns HTML. Now, whenever a function returns HTML in React.js, we call those functions components. So what we have done over here is defined a component called sidebar, which returns the HTML template that would render the sidebar in the front end. We then add the style that we defined before as an inline style on line 12. And we also bind an onClick event listener function called onClick, which gets executed every time the user clicks on this component. Now don't pay too much attention to the code if it doesn't make sense to you, but what I want you to take away from this is that JSX allows us to define the HTML, CSS, and JavaScript of a component in one location. So we can do the same thing for the top bar and the content of the page. And later on, in another location within our project, we can combine these three components to actually render the page that we have on the screen. So take note of the fact that sidebar, topbar, and content have been imported from wherever they were defined. But instead of using them as traditional JavaScript functions, React.js allows us to use them as sort of HTML tags. And that's because each of those tags return their own HTML. So by looking at this file app.jsx, it's pretty clear that our app contains three components: a sidebar, a top bar, and a content component. And when you put them together, that actually renders the page that we see on the right. Don't worry too much about line 15, I just included it for completeness, but that line essentially tells React to render the components that we defined before to create a view that we see on the right of the screen. Cool, so React.js actually allowed us to encapsulate the HTML, CSS, and JavaScript in one place in the form of JSX. And essentially when you scale applications and create much bigger applications, you could just say that your application is made up of a combination of components. And if someone ever joins your development team and they need to work on a new component or modify an existing component, they can just jump into the JSX file for that component and make the modifications as they require. Now that's much easier to do because all the code for that component, including its CSS and HTML, lives in one encapsulated location. The second benefit of using React.js is that once you define a component somewhere, they become reusable. What does that mean? Let's take a look at this component that we saw earlier on from the Facebook example. This component is just a list of users or friends or family members that are online, and by clicking on each of these components, it would open the chat bubbles which allow you to message your friends. So what might the JSX for this component actually look like? It might look something like this. So this component is just a list of users where each user represents the icon or profile picture of the user as well as their name. And in this example, there are 8 different users that are being rendered. But the beauty of using React.js is that we define the user component just once in user.jsx, for example, and we encapsulate the HTML, CSS, and JavaScript in one location. But after encapsulating it, we can use it as many times as we'd like in other locations without having to duplicate that logic elsewhere. Now that's very powerful indeed. If you wanted to achieve something similar with just HTML, CSS, and JavaScript, you'd probably have to copy over the HTML templates into multiple locations. So React.js believes in a philosophy which is you define your components once and you can use them as many times as you'd like in other locations. The third and final benefit of using React.js, which I would argue is one of its most powerful features, is that React.js automatically syncs our user interface with the state of our components. Now, what does that actually mean? Let's start off by looking at what state actually is and what it means. So let's go back to this Facebook example again, and specifically focus on this chat bubble. Now, if you've used Facebook, you know that if you click on the blue bar at the top of this chat bubble, you can either close it or open it. Consequently, we can say that in our simplified example over here, this chat bubble has 2 states associated with it. In other words, it can either be open or it can be closed. So hopefully it's clear that state is just a variable in JavaScript that stores information about what our component should look like. In this specific example, we can see that our chat bubble component can either be open or closed, and we store that information as a string. Okay, so let's forget about React.js for a second and think about how we'd implement this opening and closing logic using vanilla JavaScript with DOM manipulations. So the code for that might look something like this. On lines 1 to 5, we define an HTML template which represents what our component should look like when it's open. On lines 6 to 10, we define the HTML template to represent what the component should look like when it's closed. On line 12, we define a variable called state and initialize it to closed, which just means that initially we expect the chat bubble to be closed. And then on lines 14 and 15, we create a DOM element and set its inner HTML to the closed chat bubble template. So what this means is that initially, not only is the state of the component meant to be closed, but in terms of the user interface and what this component should look like initially, lines 14 and 15 are saying that the component should look like it's closed. On line 31, we use the document API or the DOM to get an element called chatBubbleContainer, and you can just think of this as being a div which wraps around our chatBubble template, which we defined on lines 1 to 10. So after getting this element, we add the chatBubble element that we defined earlier on as a child of this container. And then we just bind a click event listener to this on line 33 and state that every time the user clicks on this chatBubble container, we want to toggle the chat bubble. So what does toggle chat bubble actually do? If you look at lines 17 to 29, we have defined toggle chat bubble as a function which just simply checks what the current state of our application is and just inverts that. So if the user clicks on the chat bubble when it's open, we set the state of the chat bubble to be closed on line 19, but after setting the state to be closed, we need to actually update the view of the application so that what the user sees is a closed chat bubble. And that's being done on line 20 over here. So what I want you to take away from this is that every time the user clicks on the chat bubble, not only do we need to update the state variable, but we also need to update what this component should look like to the user. And if you've done stuff like this before using DOM manipulations and vanilla JavaScript, you should know that updating what a component looks like is much easier said than done. You need to be careful that you do it the right way, otherwise you might introduce unexpected behavior in your application. Now this becomes a huge problem, especially for larger applications. Now this is where React.js actually comes in and can help us with this problem. So take a look at this code on the screen at the moment. It should more or less look similar to the previous example that we had, with a few subtle changes. So we start off by defining a function called chatBubble, and from earlier on in the video, we know that since this chatBubble function returns HTML, it is classified as a component. Line 2 then seems to be making a call to a function called useState. That's a special function that comes from React.js, but I don't want you to pay too much attention or get confused by it. What I want you to take away from line 2 is that the variable state is initially set to closed, the string closed, and setState is a function that React.js provides us to actually update the state variable. Lines 5 to 11 define a function called toggleChatBubble, which gets called every time the user clicks on the chat bubble. Now this function is very similar to what we had in the previous example, with the only difference being that every time we update the state of our component, we no longer need to update what that component looks like to the user. React.js is actually smart enough to detect that there's been a state change in our component, and accordingly carry out some DOM manipulations to update what that component looks like when the user's viewing it. So that takes away the hassle of us as developers having to be aware of the intricacies of DOM manipulations and what's the right way to actually carry out DOM manipulations without introducing unexpected bugs in our application. Finally, lines 13 to 25 just check what the state of our component is and accordingly return the corresponding HTML template for the component. So if our component has a state of open, then we return the HTML that renders an open chat bubble on the screen. But if the state of the component is closed, then we render the HTML template that corresponds to a closed chat bubble. So now when you look at these three advantages of React.js, hopefully they make a bit more sense to you. That's it for this video, and hopefully by now you have a deeper appreciation of what React.js is and why it was developed. So thanks for watching, and I'll see you in the next one.